going to talk about an example of where this has been used to save a sewer agency a whole bunch of money without any additional risk of overflows. A little bit of history. I mean, I'm sure y'all here are really familiar with the Clean Water Act and living and breathing it every day. So around, one of the things that EPA has been putting in place is the CMOM program, Capacity Management Operations and Maintenance, is to use a series of incentives to get agencies to put more emphasis into operating, maintaining their sewers to prevent them from clogging up and overflowing. And there's been successes. Here's an example from San Diego. High frequency cleaning has resulted in a significant reduction in overflows over the course of the last 15 years. Significant, but at what cost? So classic cleaning tools, aggressive cleaning, go out on a schedule, clean every month. Go to those places where you have some historical information saying, this is overflowed a lot, we better get out there and clean it frequently. That's kind of expensive going out there and doing that. Oh, while you're there, you can do some condition assessment, take a look with the CCTV, see what it looks like down there, and that can inform your capital improvement program. Let you know where you need to go do some refurbishment or replacement. It works. Nothing wrong with it, but it can be really expensive. And what you wind up finding out is, you could be going out and cleaning when you might not need to. And that's using personnel, equipment, management, capital funding for trucks. Not to mention that also you're putting trucks on the roads. That's increasing traffic. You're increasing the incidences or the risk of injury and illness amongst your workforce because now they're out there more doing things that maybe they don't have to do. Confined space entry, all sorts of fun stuff. And it can accelerate the wear on your pipe. So now there's technology available. The Internet of Things we're calling it, sounds like a cute buzzword, but it's technology that connects together devices in a way that lets us analyze data smarter and faster than we ever could before. So we can now monitor inexpensively and in real time understand what's happening out there with our sewer system without having to look at it. Oh, went the wrong way. The methodology of how this works, we monitor water levels at manholes. It's usually the most convenient place to put the water level sensor. This particular system connects up with a satellite network that brings that data around and back to servers. Those servers then can analyze the trends occurring in that data, and that can inform us, the managers of our sewer systems, of when we need to get out there and take a look and see what's going on. Reason is, because when we look at the data, if your sewer could talk, it's as if your sewer's talking to you when you look at the data. Now let's look at a couple examples, then we'll get into the case study. So typically, what you see in your sewer when you're looking at this level sensor data is you see a diurnal pattern that repeats itself most all the time. It's normal, nothing's changing. This data is sensitive enough that we can see when changes happen in it. So here's an example here where we see a pretty clear distinction. This is a real sensor. A pretty clear distinction that there's been a change in a diurnal pattern. And we can write the algorithms in the database to identify the changes in those trends, the percent difference that represents a change, significant enough change based on historical data, that says, well, we should go look at that. Something looks like it's starting to clog up downstream. Some grits may be building up or something. So we could be at risk when it rains. So here's another situation that's quite interesting. Here's a significant change. The diurnal flows went down. So that tells us, well, wait a minute, something is not letting that water through upstream. There's been some change upstream. We should go take a look at that. So now, instead of going out and cleaning on a schedule, we can actually use the data to tell us when we need to go out and look at things. And we'll talk about the case study in San Antonio, and Aissa will talk about that, and about how that has helped them reduce the frequency of cleaning substantially.
Thank you, Richard. So San Antonio is one of the largest municipal utilities in the United States. We provide water and wastewater services to over 1.7 million people. And we have about 5,200 miles of sewer main, 100,000 manholes. We have 300 side pins, which is pretty much my least favorite part. 156 lift stations, 80 miles of force main, and then we have 3 wastewater treatment plants. One of them is the larger centralized regional one. We began using smart covers, which are manhole level monitoring devices, back in 2009. We started small, just like you would with any program. And I think we had about 10 initially. And then we did this in anticipation of a consent decree that was lodged against us in 2013. And basically we were trying to predict when we would need to go out and do maintenance on our collection system. But initially we put the smart covers in places where we knew we had structural defects on pipes, and we were babysitting those structural defects because we didn't have the capital dollars to fix every single pipe we knew had a structural defect in that year. And so we would put the smart cover there. That program's now grown to over 300 smart covers that we have scattered throughout our system, many of which are still on pipes that have structural defects that we can't fix this year, that we know we're going to fix during the consent decree period, but we're trying to space it out so that we spend about the same amount capital dollars wise each year so that we can manage all of these projects that we have. So the pilot that we did, a big distinction between these smart covers that we deployed for the pilot versus the other ones is that these were put on pipes where we have a high frequent cleaning schedule. So we have about 200 pipes in our system that are on a 1 month frequent cleaning schedule, which means I send one of my combo operators out there once a month to clean that pipe. And then we have another almost 300 pipes that are on a 3 month frequent cleaning schedule. So the pipes that we chose for the pilot, we chose 10 manholes upstream of pipes on a 1 month frequent cleaning schedule. And then we agreed that starting in July of last year till July of this year that we would only clean those pipes when we needed to, based on the smart cover data, so the Internet of Things, and based on going out there, based on an alarm or a trend that was trending upward. And so that way we were using real-time data instead of just a schedule like we were doing. And so the agreement was we would analyze this at the end of the year, see if the pilot was successful for us, because we weren't sure if it was going to be or not, and then make decision from there how we were going to continue with the program. So here's an example of one of the sensors data that came back. As you can see, this is a manhole that's the levels trending upward. And so what this does for us is that instead of just sending a combo out there, or a Vector truck, whatever you call it, after a month, we would send them out there once this trend got to a point where we no longer felt comfortable. So we could better schedule that and send them out there when they're cleaning a nearby pipe, instead of sending them out there like we do now, where San Antonio is 1,200 square miles, or Bexar County is 1,200 square miles. Texas, everything's bigger. So when you send out a combo truck, which is a $300,000 piece of equipment, to the east side of town, and then you have to go chase another 1 month pipe on the west side of town, you're wasting a lot of gas, and you're taking some risks because you're sending a huge piece of equipment out in traffic. So basically we're using trends here instead of just a schedule to make better decisions about when we're going to send out our resources. And so the program was extremely successful. If we had just cleaned those pipes per our schedule, we would have cleaned 120 sections of pipe, where we would have had 120 cleanings versus the 7 that we ended up having based on alarms from the real-time data we were receiving from the deployed smart covers, the 10 deployed smart covers. So that's a 94% savings, and how often I had to roll a combo to those 10 sections of pipe. And so that's a huge savings, and basically we conserved resources that we can now use for system-wide cleaning. So in our system, there's pipe that's, we call it virgin pipe, that's like PVC on the north side of town where it's just developed, and we haven't cleaned it yet, but we do find that we have overflows there every once in a while because the contractor left a present for us and forgot to remove something at the end of construction. Even though we do post-construction televising, sometimes that televising isn't always timed right. So it's done before they finish the asphalt or before they finish some concrete, and so then they leave presents for us that we find sometimes a year later. So what does this equate to in savings? So if we take all of those pipes in our system, the ones on 1 month and 3 month cleaning frequencies, and switch it over to where we only have to clean them when the real-time data tells us to, we're thinking we could save anywhere between $2,500 to $4,000 per asset, per pipe. So that's a huge savings, because then we're not rolling a combo out there with 2 guys in it in a $300,000 piece of equipment using the gas. We reduce our carbon footprint. And then we also are able to go clean. There's an opportunity savings that we can go clean system-wide pipe in some of those newer neighborhoods where there may be something lurking in the sewer line that we don't know about yet that will save us a sanitary sewer overflow. And so there's about 600 miles of pipe in our system that we're just not able to get to right now because we have so much frequent cleaning that we have to do based on the schedule and what we're trying to do to stick to our consent decree and reduce overflows. So just to sum it up, we're using this real-time level monitoring data and the Internet of Things to drive down our maintenance costs. And there's straightforward cost savings associated with this, such as fuel costs, equipment wear and tear. And then we're also modifying our cleaning frequencies based on this data. So we can use what the trends tell us and adjust our cleaning frequencies in our program that we use to track that. And so there's all those benefits from this. And so then now we have a more efficient use of our resources, and we can use our crews to clean system-wide pipe. We can be a little bit more efficient with routing because we can try to put a pipe that's trending upward on one of the manhole level trends with another pipe that they're cleaning that's a system-wide pipe, and they can go to 2 pipes in the same area as opposed to skipping around the city, which is a huge city, and wasting gas and wasting time. And one of the things with system-wide pipe is that we can clean upwards of 20 sections in a day if we're doing consecutive pipes or pipes in the same area, versus 10 pipes a day if we're doing pipes that are scattered throughout the city. So what we're looking at, what are we doing next? So SAWS is, obviously any sort of new program has to be budgeted. So SAWS is currently in the process of looking at budgeting a expansion of this pilot because it was hugely successful, and we see this as a way to really optimize our cleaning frequency, our maintenance and our cleaning frequencies. And so what we're thinking is that we would deploy this on a lot of our 1-month pipes. So pipes that my guys in the sewer maintenance division are having to go to every month because maybe they're downstream of a taqueria or they're at near an industrial user that isn't quite perfect with their fog program. So we have a lot of these pipes. We have about 200 of these, and then we also have another 300 pipes that are on a 3-month cleaning frequency. So we're looking at least a deployment of about 200 additional smart covers to basically look at pipes that are on high cleaning frequencies and try to reduce that time that I'm having to send guys out, and that way we can do more maintenance of pipes that we're not getting to right now. And hopefully all of this will help us continue to drive down our sanitary sewer overflows. San Antonio right now is sitting at about 4 sanitary sewer overflows per 100 miles per year, and our goal is to get down to less than 2. We're a really big system, and we have a lot of projects that are large CIP projects that are they're at least 3 to 5 years out, and we're thinking that a lot of our inflow related SSOs will go down once we get to that. But this is a huge help. We have seen so much of a decrease in sewer overflows attributed to grease, roots, and debris because of smart covers, and then also just our implementation of a frequent cleaning schedule that's based on each pipe, what we've seen from condition assessment of each pipe. And with that, if there's any questions for Richard or myself?
What's your cost per smart cover?
I guess. Oh, they asked us cost per smart cover. I'm not sure. I think it varies based on what your program would be.
Yeah, I don't have the data for cost per smart cover, but I'm sure you can contact smart covers and get a quote.
Yes.
Did you TP the monthly flushes where you have a problem? Did you TP the lines to see what the problem is?
Yeah, so the question was whether or not we televise the mains where we have a monthly frequent cleaning schedule currently, and the answer is yes. That most all of the mains in our system that are concrete or clay, which are the ones in the areas with the most density for the frequent cleaning schedules of a month or 3 months, have been televised per the consent decree, because we had to do condition assessment to determine the remedial measures that we were going to follow. And so a lot of those pipes that are that have smart covers babysitting them for a structural reason have of course been televised, and then the ones with roots, grease, and debris, a lot of the pipes that have smart covers had a previous sanitary sewer overflow, and per our consent decree we have to do post-televising for every sanitary sewer overflow. And so we do go assess what happened, what was the cause of when we do a root cause analysis for every single SSO that we have. So yes.
I can answer that question. For North Carolina, it's about $5,000 per unit in North Carolina.
I have a question. You say you have that consent decree that says, you change the fee. Are you negotiating with, EPA to reclassify clean with the smart code?
Not that I know of, we're not trying to change the amount of cleaning that we have to do. We're just trying to, we're cleaning based on, a cleaning schedule determined from findings that the operators put into our computerized maintenance management system. But there's no dictation from EPA as to how many feet we have to clean. The main, goal of our whole consent decree is to reduce sanitary sewer overflows. So this, even reducing the amount of cleaning we do by being smarter about it, will still achieve that same goal. Yes, sir.
Unless you take an elevation differential, are you kind of just looking at one pipe segment having issues, or just multiple pipe segments? When you get into great elevation changes where the upstream manholes, elevation changes more significant, you know, we're gonna have an overflow before that one monitor is detected.
So the question, it was a long question, so I'm not sure if I'm gonna be able to repeat it accurately, but you're talking about whether or not we have multiple pipe segments sometimes on a cleaning frequency that are kind of tied together based on elevation changes and.
Most of your sections, are you just kind of monitoring one section of pipe, or is it multiple sections?
Whether or not we monitor multiple sections of pipe with one smart cover. So we do monitor multiple sections of pipe with one smart cover, because what we'll do is we'll tie 2 or 3 sections that we know have been problematic into one cleaning frequency, and so we will put those 2 or 3 sections all on a 1 month or all on a 3 month, because we're trying to chase down like the grease problem, and if there is a wide difference in slope between those 3 sections, maybe we want to make sure that the more shallow pipe is where the smart cover is, but we chase it down to the end section, maybe where there's a T or something. So we do tie things together. Sometimes a lot of them are just on pipes where there's a structural defect right now. That's how we have them deployed, and it's just one section. But in the case of this, we will have multiple pipes tied together on a frequent cleaning schedule of 1 month or 3 months, based on just chasing the problem down until we know we've got it cleared.
But you're typically pretty flat.
No, we have 1,000 feet of elevation difference from the top of our system to the bottom of our system, but our sanitary sewers lines are relatively low slope. Coming into the treatment plants, but up in the northern section of the city where we get into the Texas hill country, like not hills compared to where some of you guys are from, but hills for us, and it does get pretty widely variable in elevation.
Any other questions?
Yes, sir.
Yes, sir, you said that y'all, you do the mic, I'm sorry.
You know, go to the mic.
Yeah, oh, you, I'm sorry.
Yes, ma'am, you said y'all are under the consent decree, correct?
Yes, sir.
Let me ask you this, do y'all keep a calculation of how many spills y'all have per year?
Yes, absolutely. He asked whether or not we keep a calculation of how many spills we have per year, and pretty much every day there's an email sent out to all of us within management and our executive management saying how many spills we've had, and then we actually do a root cause analysis of every single spill and track caused by, or the type of spill, and we graph that to make sure we're on a downward trend for each type of spill. So whether or not it be a frequent cleaning related spill would be roots, grease, debris, but then we also have contractor caused spills. Right now Google's installing fiber throughout our city, so we categorize every single thing so that we can maybe make decisions to change things if we see anything trending upward.
In that category, do y'all say if it's a spill to the states of the water, or overflow just on the surface of the ground, or it enters somebody's house? Or do y'all categorize those in 3 different, or?
Well, we have the report that gets sent into our regulatory agency, Texas Commission on Environmental Quality. It's called a 5-day report. It has whether or not it went into water to the state, anything like that. So all of that's categorized as well.
Is there a special form that y'all complete?
We do. We have a special form, and I'm sure it's pretty consistent in Texas. And so I would guess every state regulatory agency has their own special form.
Okay, that was gonna be my next question.
I'm
Thank
sure
you.
you could get ours off the internet, or
Okay.
if you give me your card, I can find it.
Thank you.
And looking at your overall system, do you have any idea how many smart cover percentage-wise you'll need?
Well, he asked how many smart covers we might need, And so we're currently looking at deploying them on all of our pipes that have a 1-month cleaning frequency, and then also on some pipes that have a 3-month cleaning frequency. And so the number that I was told for budgetary purposes for next year is 225 additional smart covers, and we already have 300. But that number may or may not change just based on whether or not we want to include all the 1-month and 3-month pipes that we have. So that's, for us, that, I mean, it's be scalable because we have 5,200 miles of sewer and most people have a lot less than that. So we just have a big monster of a system.
Can you move these covers around?
Well, that's something we're thinking about. If we get a very good feel for a specific site in terms of the trend, we may or may not decide that it's safe to move it. Because the thing is, once we go to a schedule based on the smart cover data, then if we feel really good and that repeatedly is working for us, we may be able to move that smart cover in a year or two to a different location.
Thank you.
Thank you.
And to kind of follow up on that, the smart covers are being applied primarily for monitoring for overflows, and now it's going to be for informing cleaning frequencies. There's an analysis being done to evaluate how much monitoring would help for I&I isolation. And that may have a different approach in terms of density of coverage.
Right, we have a goal as part of our capacity constraint modeling to do a 30% inflow reduction in our system, and so we plan on also using smart cover data to help with that. Because we just can't afford, if we didn't assume any I&I reduction, we just can't afford the magnitude of capital program that we would be required and the size of the pipes we would be required to put in to address our peak flows.
Well, I tell you what, Richard was such an energetic speaker that while he was up here bouncing around the stage up here, I think I gained 10,000 steps on my Fitbit. So thank you. But let's put our hands together for this. We have about 9 more minutes before our next speaker.